Welcome back to my channel. Today here we discuss the law of radioactive decay and Geiger-Nuttel rule. This is our second lecture. First lecture here we study the some basic concept of atom and the isotopes and the radioactive decay. Our point is law of radioactive decay and Geiger-Nuttel rule or law. In 1911, Hans Geiger, a physics professor and a graduate student, John Nuttel, at Rutherford Manchester Laboratory research on alpha particle and give a law which is known as the Geiger-Nuttel law or rule. Geiger and Newton, they are two different scientists, and he discovered in 1911 at the Rutherford Manchester Laboratory both research on alpha particles and gives one law, and this law is known as the Geiger-Newton law, or also called as the rule. 1911 मध्ये हन्स जिजर या फिजिक्स प्रोफेसरने आणि ग्रॅज्युएट स्टुडंटने जॉन न्यूटन ह्या दोघांनी मिळून रुदरफोर्ड मँचेस्टर लॅबोरेटरीमध्ये रिसर्च केला होता अल्फा पार्टिकलवरती. आणि त्या दोघांनी मिळून जो रिसर्च केला त्यांनी एक लॉ डिस्कवर केला आणि त्या लॉला त्यांच्या दोघांच्या नावावरून देण्यात आलं आणि त्यालाच जीजर न्यूटन लॉ किंवा रूल सुद्धा काही वेळेस यूज केलं जातं. दिस लॉ गिव्ह द रिलेशनशिप बिटवीन द disintegration constant. Here disintegration constant we already see, also known as the decay constant, lambda of the alpha emitter and the range capital R of the alpha particle in air emitted by it. Suppose this is our simple body, and this simple body is emitted the alpha particle. ज्यावेळेस एनर्जी लॉस करतो ही बॉडी, त्यावेळेस एका पॉईंटला ते याची एनर्जी संपून जाते इथं सपोज. आणि हा जो गॅप आहे डिस्टन्स बिटवीन दिस टू, and this is called as the range. So this is range, and we noted as capital R. This law, the relation, the one with the relation, and the relation between the disintegration constant lambda of the alpha emitter and the range capital R of the particle in air means here range means any body, म्हणजे कोणती पण बॉडी घेतली आणि तो एनर्जी लॉस करतो एका पॉईंटला एनर्जी लॉस करत करत ती याची एनर्जी पूर्ण संपते आणि इथून ते एनर्जी संपेपर्यंतची जी डिस्टन्स आहे त्याला आपण रेंज म्हणतो. अँड दे फॉर्म अ रिलेशनशिप बिटवीन द हाफ ऑफ द alpha emitter to the square root of the energy q, square root of energy q of the alpha particle emitted, and plot a curve corresponding to their relation. On the basis of experimental study, here only what is Giger related the range r of the alpha particle in the air with the initial velocity. Initial velocity v naught if the of these particles. So range, Giger use one equation, the relation between the initial velocity v and the range is r equal to a into v naught q, where r is in the meter and v naught is meter per second. The value of a, this is a constant, and the value of a is 9.6 into 10 raised to the power minus 24, and this relation is called as the Geiger's law. The initial energy of alpha particle is denoted E naught. Here we give initial velocity is V naught. So energy also we give here E naught, initial energy give here E naught. So we have the equation E naught equal to 1 half capital M into the V naught square. So here M is the mass of the particle, and using this equation in llGeiger law, we get here we have R. The value of R is 0.00318 E naught raised to the power 3 by 2, where E naught is electron volt, mega electron volt, by using the value of the range by the equation and relate them with the decay constant or disintegration constant lambda, and they establish that if log of range R of alpha particle in air plotted against the log of corresponding value of decay constant lambda of various radioactive elements emitted this alpha particle, and the line is the straight line curve obtained by for the radioactive series. We can see here the log y versus log r. Here we also here see the value of range given by the equation, relate them with the decay constant lambda, and establish that log of range r of alpha particle in air plotted against log of corresponding value of decay constant or disintegration constant log lambda of various radioactive element. कोणता पण रेडिओएक्टिव्ह एलिमेंट घेतला जो काय करतो अल्फा पार्टिकल इमिट करतो, तर आपल्याला ग्राफ काय मिळतो लॉग आर वर्सेस लॉग लॅम्बडा. वी हॅव द graph plot is the straight line. Here we give three radioactive element. Here is the uranium series, thorium series or actinium series. Mathematically this equation mathematically we can write like this: log log lambda equal to a log r plus b. Log lambda equal to a log r plus b. Equation is the straight line, and this equation is called as the Nuttel law. Therefore, the radioactive isotopes with faster rate of decay emits the alpha particle having greater range, or vice versa. They form a relationship between the half-life of alpha emitter is inversely proportional to the square root of energy Q of alpha particle emitted. So here plot a graph square root of Q versus P half. The here also three series, uranium, thorium, and actinium series. The value of T1 half, which is inversely proportional to square root of Q, means Q energy of alpha particle. So we have the equation log to the base 10 T half equal to a plus bz divided by under root Q, and z is the here z. This z is the atomic number of daughter nuclei. T1 half life of the alpha particle, and Q is the T1 half life of the alpha particle, and Q is the energy of alpha particle.